Welcome to qnawire.
Okay, so let's say you have a reaction where you have 2 moles of hydrobromic acid decomposes to form 1 mole of hydrogen gas and 1 mole of bromine gas. So if you were to express the rate of this reaction in terms of the concentration of each of the reactants in the products, this is something of what the rate would look like. So you want to look at the rate is going to be equal to -1 over the coefficient, which in the case of HBr is -1 over 2. And this is going to be multiplied by the change in concentration of HBr over the change in time. And this is going to be equal to the increase in the change in concentration of our hydrogen gas divided by the change in time, which is going to be equal to the change in the concentration of Br2 over the change in time. And so this makes sense. One thing that you want to note is if you look at the signs, they make sense because you're decreasing the amount of your reactant, so you should have a negative sign, and you're increasing the amount of your products, so you should have 2 positive signs. Actually, let's get rid of those. Okay, so this would be the rate of the reaction. So in order to figure out the average rate of the reaction, so we're going to call this rate average, of using the concentration of HBr, where you have a change in concentration and a change in time, what you're going to want to do is now look at -1/2, where you have your concentration of HBr at time 2 minus the concentration of HBr at time 1 divided by time 2 minus time 1. And so in this case, this is going to be equal to, you're told that you have an initial concentration of 0.600 minus a second concentration of 0.512, and this is going to occur over the first 25 seconds of the reaction. So it would be 25 seconds would be time 1 minus 0 seconds. Sorry, 25 seconds would be time 2 minus 0 seconds would be time 1. And so now if you were to go through and multiply everything out, you would get a rate average would be equal to 1.76 molarity per second. So that would be the rate for this reaction. So let's actually go into another tab. So from part B, the rate is going to be equal to 1.76 times 10 to the -3 m per second. And I actually think I forgot to write that here. Times 10 to the -3. Okay, so for part C, if the volume of the reaction is taking place in 1.5 liters, what would the amount of B2 in moles be during the first 15 seconds of the reaction? So right now, this is the rate of the reaction for HBr. But based on this initial rate equation, you know that this rate, which we just determined, is going to be equal to this rate of Br2. So this is going to be equal to the rate where you're looking at Br2. So the first thing that you can do for this reaction is you have 1.76 times 10 to the -3rd times molarity per second, and you just want to look at this reaction over the first 15 seconds. So you can multiply this by 15 seconds, and now you get a concentration of side, it's not 1 point. It would be 2.64 times 10 to the negative 2 m. And you know that this concentration, so 2.64 times 10 to the negative 2, which is in moles per liter, is in a reaction vessel of 1.5 liters. So if you multiply that out, cancel out your units, and now you get a final answer of 0.0396 moles, which is about 0.04 moles.